Welcome to our deep dive into the wild and unpredictable climates of super-Earths. These aren't your average planets, folks. We're talking about massive worlds, bigger and heavier than our own Earth, with the potential for some truly mind-blowing weather. Imagine hurricanes that could swallow continents, lightning storms that could light up the galaxy, and winds that could circle the planet in hours. So, buckle up, space fans. We're about to embark on a journey to understand the awe-inspiring power of nature on a scale you've never seen before. So, what exactly are we talking about when we say super-Earth? These are planets beyond our solar system, exoplanets that share some similarities with Earth but are significantly larger. We're talking about planets with a mass greater than Earth's, sometimes up to 10 times greater. Now you might think, bigger planet, bigger everything, right? And you wouldn't be wrong, but it's not just about size, it's about what that size means for the planet's composition and atmosphere. You see, super-Earths come in a variety of flavors. Some are rocky, like our Earth, but on a much grander scale. Imagine mountains that dwarf Mount Everest and canyons that stretch further than the Grand Canyon. Then, there are water-rich super-Earths, planets covered in vast deep oceans that could make our own Pacific Ocean look like a puddle. And if that wasn't enough, we have the gas-heavy super-Earths. These behemoths possess thick atmospheres, much denser than ours, composed of elements like hydrogen and helium. These atmospheres play a crucial role in the extreme weather conditions we'll be discussing later. Many of these super-Earths exist in what we call the habitable zone around their stars. That means they orbit at a distance where temperatures could potentially allow for liquid water on the surface, a key ingredient for life as we know it. But hold on a second. Just because a planet sits in the habitable zone doesn't mean it's a tropical paradise. The climate on these super-Earths can be incredibly diverse and, in many cases, downright extreme. So, while the possibility of life on these distant worlds is tantalizing, their extreme climates could pose significant challenges. Okay, so we've established that super-Earths are big, diverse, and potentially habitable. These planets, which are larger than Earth but smaller than ice giants like Neptune, offer a fascinating glimpse into the variety of worlds that exist in our universe. But what about these extreme storms we keep hearing about? What makes the weather on these planets so dramatically different from what we experience here on Earth? Why are they so much more intense than anything we experience here on Earth? The answer lies in the unique conditions that prevail on these massive worlds. Well, it all boils down to two main factors: gravity and atmosphere. These two elements work together to create the perfect storm, quite literally. Remember that super-Earths are significantly more massive than Earth. This increased mass has profound implications for the planet's weather systems. This increased mass means they have a stronger gravitational pull. This stronger gravity affects everything from the planet's atmosphere to its surface conditions. Now, gravity plays a crucial role in atmospheric pressure. The stronger the gravity, the more it compresses the atmosphere, leading to higher pressure. The stronger the gravity, the denser the atmosphere. This density is a key factor in the formation of extreme weather patterns. And a denser atmosphere means more of everything: more air molecules, more moisture, and more potential energy just waiting to be unleashed. This combination sets the stage for some truly spectacular storms. Think of it like this. Imagine a pot of water simmering on a stove. The heat from the stove represents the energy from the star, and the water represents the atmosphere. The heat from the stove represents the energy from the star, and the water represents the atmosphere. As the heat increases, the water becomes more turbulent. On Earth, it's like we have a small pot simmering gently. The energy input is relatively moderate, leading to milder weather conditions. But on a super-Earth, it's like we've swapped that pot for an industrial-sized cauldron with the heat cranked up to 11. The result is a much more dynamic and volatile atmosphere. This increased energy in the atmosphere translates to faster winds, some reaching unimaginable speeds. These winds can be several times stronger than the most powerful hurricanes on Earth. We're talking about winds that make Earth's most powerful hurricanes look like a gentle breeze. The sheer force of these winds can reshape the landscape of the planet. These winds whip up the dense atmosphere, creating colossal storms that could engulf entire continents. The scale of these storms is truly mind-boggling. And if that wasn't enough, the increased atmospheric density also amplifies the power of lightning. The electrical discharges in these storms can be far more intense than anything seen on Earth. Some super-Earths have such thick atmospheres that they create permanent cloud layers, shrouding the planet in a perpetual twilight. This constant cloud cover can have a significant impact on the planet's climate. These clouds aren't your average fluffy cumulus clouds either. They are massive, dense, and capable of producing extreme weather events. We're talking about massive, swirling storm systems that stretch for thousands of miles, constantly churning and brewing up extreme weather. These systems can last for weeks or even months. Take, for example, the exoplanet HD 189733b. This gas giant, located about 63 light-years from Earth, is a prime example of extreme weather. This gas giant, located about 63 light-years from Earth, is a prime example of extreme weather. Its atmosphere is constantly bombarded by intense storms and high-speed winds, making it one of the most turbulent places we've ever discovered. Chapter 3: Types of Super-Earth Climates. We've talked about the intense storms and extreme weather conditions that can arise on super-Earths. But let's dive a little deeper into the different types of climates we might encounter on these alien worlds. These climates can be as varied and fascinating as the planets themselves. Just like in our own solar system, where we have everything from the scorching heat of Venus to the icy plains of Mars, super-Earths exhibit a remarkable diversity of climates. Each of these climates presents unique challenges and opportunities for any potential life forms. First up, we have the extreme heat worlds. These planets are, as their name suggests, incredibly hot. The heat on these worlds can be so intense that it shapes the entire landscape. We're talking about surface temperatures that could melt lead. Imagine a world where the ground itself is molten and rivers of lava flow freely. These scorching temperatures are often due to their close proximity to their host stars or the presence of a thick, heat-trapping atmosphere. This combination creates a furnace-like environment. One such example is Kepler-10b, a rocky super-Earth located about 560 light-years from Earth. This planet is a prime example of an extreme heat world. This planet orbits its star so closely that its surface is tidally locked, meaning one side always faces the star, while the other remains in perpetual darkness. This creates a stark contrast between the two hemispheres. The day side of Kepler-10b experiences temperatures exceeding 2,500 degrees Fahrenheit, hot enough to melt rock. The night side, in contrast, is much cooler but still inhospitable. Next, we have the ocean worlds. These planets are covered in vast, deep oceans, potentially hundreds of miles deep. These oceans could harbor life forms very different from those on Earth. Unlike Earth, where our oceans are relatively shallow compared to the planet's radius, these water worlds are dominated by their liquid water. The sheer depth of these oceans is mind-boggling. One intriguing example is Toei 1452b, located about 100 light-years away. This planet is a fascinating subject for scientists studying ocean worlds. This planet is thought to be a water world with an ocean that makes up a significant portion of its mass. The potential for unique marine ecosystems here is immense. Finally, we have the stormy ice giants. These planets are similar to the gas giants in our solar system, like Jupiter and Saturn, but they're significantly colder. Their atmospheres are often turbulent and stormy. These planets are often located further away from their stars, resulting in frigid temperatures that freeze their atmospheres into thick layers of ice. The storms on these planets can be incredibly fierce. One example is Gliese 581c, a super-Earth located about 20 light-years away. This icy world is a testament to the incredible variety of climates that exist in our universe. Chapter 4. Could super-Earths be habitable despite their storms? So far, we've painted a pretty intense picture of super-Earth climates. We've got scorching hot surfaces, crushing ocean pressures, and storms that could make even the bravest astronaut think twice. But amidst all this chaos, could there be a chance for life? Could these seemingly inhospitable worlds actually harbor life as we know it, or even life as we don't know it? Well, the answer, as with many things in astronomy, is a resounding maybe. You see, while extreme weather might seem like a deal-breaker for life, it's important to remember that life is incredibly adaptable. Here on Earth, we find life thriving in some of the most extreme environments imaginable, from the scorching depths of hydrothermal vents to the frozen wastelands of Antarctica. So, while those hurricane-force winds and planet-sized storms might seem daunting, they don't necessarily rule out the possibility of life. In fact, some scientists believe that certain features of super-Earths could actually enhance their habitability. Take, for example, their thick atmospheres. While we've talked about how these atmospheres can contribute to extreme weather, they also provide a crucial surface protection from harmful radiation. Earth's atmosphere shields us from the sun's harmful rays, And the denser atmospheres of super-Earths could offer even greater protection. Then there's the matter of water. We know that liquid water is essential for life as we know it, and many super-Earths are thought to have abundant water resources, whether in the form of vast oceans or subsurface reservoirs. And let's not forget about magnetic fields. Earth's magnetic field acts as a shield, protecting us from the solar wind, a stream of charged particles constantly emanating from the sun. Super-Earths, with their active cores and rapid rotation, could generate even stronger magnetic fields, providing an extra layer of protection for any life that might exist on their surfaces. Of course, not all super-Earths are created equal. Some, like those scorching hot lava planets we talked about earlier, are likely far too extreme for any life to survive. But others, particularly those located in the habitable zones around their stars, might offer conditions conducive to life. With advancements in technology, our ability to study these distant worlds is improving, giving us more clues about their potential habitability. As we continue to explore and learn, the possibility of finding life on these stormy yet fascinating super-Earths remains an exciting frontier in our quest to understand the universe. Chapter 5. The Future of Super-Earth Exploration. Super-Earths are some of the best candidates for finding alien life, but their extreme storms could make survival difficult. Whether they are stormy water worlds, lava planets, or frozen giants, they challenge our understanding of planetary climates. If we ever visit a super-Earth, we'll need to prepare for storms unlike anything Earth has ever seen. But hey, that's part of the adventure, right? Exploring the unknown, pushing the boundaries of our knowledge, and maybe, just maybe, finding evidence that we're not alone in the universe.